Hello? I know we've enjoyed enough. Please, let's move from the back and occupy the spaces in front. I want to see some people moving, please. Let's bring our conversations from the back to the front. Yeah. Yes. So, our brothers and sisters from the high school have left us, so we want to fill the middle seats first before we move to the other sides. So please, let's come. Let's keep coming. Please, let's keep coming. Those on my left, please move to the middle. Those on my left, some of you are looking at me. Please move. Please, if you move, don't go and sit at the back. Oh, come forward. Come forward. Hello, citizens of the left, please move to the citizens in the middle. I'm giving you a visa from Ghana to Canada or UK. If you want America, we can sort it out too. Please don't sit at the back, come forward. I can see a lot of spaces here and here. There are enough spaces here that you and your friends can. Please, not the edge, in the middle. All those disobeying, you've already cancelled your name from the gift, so don't even bother. You can come here. Is there a seat there? Is there someone? Is there a seat there? Thank you for moving. Those at the far right, please move to the side. Is there something on the seat? No one is there. Empty. Somebody's there. And the seats at the back there. No one. Somebody's there. What about the one behind it? Nobody's there, please. Okay, if there is a seat in front of you with no bag, move. The Canadians are very obedient. I don't know about the UK people. You let me move to UK because I like UK. So maybe if I come here. British people, English people, those are the far back. Please move forward. I hope we have updated our social media profiles with our selfies and what we've learned in the first should I say first half or say I've promoted you to this side to Canada, from Ghana to Canada. Yeah, we learned there's a protest there, so we've moved here. Those who haven't updated their socials, please, we have 2 minutes to do that. Then the next speaker will come up. All right. As you update, let me take. I said I'll give you a shout out too. It's coming. Don't worry. Don't forget to tag Ghana, that's GH Data Science, on IG and Twitter. Then Ghana Data Science Summit on LinkedIn. If you don't have a LinkedIn account, make sure you create one. If you need assistance, see any of the volunteers or organizers after the session. They'll help you create. Don't forget to put down the names of the speakers and follow them and have a good relationship with them. Okay. Sweethearts, I'm waiting for you, so let's come here. Yeah. We are all waiting for you people. Okay. Thank you all very much for, you've been the best audience. Clap for yourself. Oh, energy. The best of the best we've had so far. So attentive. You are here. It's one thing to go for an event and not be there. You've been here. So I want to introduce the next speaker. He is a research engineer at Google research team in Accra. And currently, his work focuses on using AI for weather forecasting in low-resource regions. Prior to Google, he worked as a machine learning engineer in various startups in America. You won't say you'll be there. You don't want America. Who will be in America soon? Okay, I'll be with you, okay? In my dreams. All right. So let's give that for Mr. Santiago Portes as he gives us his talk on weather technologies. Oh, give that for him as he joins us. Yes.
Okay. So I think you can hear me, right? Okay, perfect. So I will mainly talk about weather today. So the thing with weather is that it's kind of important in our lives. Rainy day can like spoil your plans. So if you want to go to the beach or do like some fun outside, you kind of rely on just having nice weather. And sometimes you want to commute and you expect the weather to behave. And of course, this is the case for most humans. Like we are really small and we depend on all the stuff that changes in our environment. And because of that, weather forecasting technologies have been super useful. In particular, the weather products at Google, it has around 1 billion users per month. So every day, around 1 billion persons in the world search for how is the weather in Google, and they use that information to plan their day, maybe decide whether they need to an umbrella or like the kind of clothes they want to use. And of course, there are some infrequent but really severe events that can impact our lives. So sometimes it rains and the city becomes flooded. And that can be really dangerous because it can kill persons and can destroy business, and it can cause a lot of money to a government or to individuals. So it's definitely a key technology. So yeah, weather forecasting is kind of important, I guess. So the thing is, like, let's try to talk a bit of how weather forecasting works first before talking about machine learning. And like everything, it starts with data. And in our case, these data are just observations. So the US and Europe and multiple governments around the globe have made big investment in infrastructure to collect weather data. So weather is kind of a weird area because like all the governments agree that they want to be friends and share data between each other. So there is another community in the United Nations that basically all the countries that are part of that group share all their data for free with no limitations with all the other states that are members. So the main reason for this is because the weather in some part of the world can affect the weather in the rest of the world. So in order to get an accurate forecast, we need global data at the scale. So let's say we as a humanity have built a big infrastructure just to collect weather data because we consider that as important. The problem with the weather data in general when we are collecting is that we cannot get data in every point of the earth. Like it's kind of impossible to know exactly if in this auditorium it's raining at a particular point. We might know that it's raining in a particular station close to here, but not exactly here. So let's say that the models that we use to predict the weather, they are just like simulations that they take the current state of weather and try to predict what will happen in the future. And in order for that to work, we need to have dense observations. The good thing is that we can have like a forecast from the past that is kind of like the reality of the model. In the statistic terms, we can say that it's like the prior of how the world will look like, the environment will look like. And using that observations, we can update the results of the model. That's usually called analysis. And we basically take the data that we have available and we try to improve the forecast in such a way that it better predicts the data. So what is happening here is that we take, let's say, the forecast for an hour ago, that is a dense field, and we try to improve it using the observations that we have available. So in that way, we can have the best possible estimate of how the weather look like. And when we have that, we can just run these really expensive simulations around the globe and predict the weather in a particular state. So this is basically how most weather models work right now. Yeah, that's it. Something interesting is that we have been making a lot of advances in the last couple of decades. And we have never had like an eureka moment on the weather forecast. So it doesn't seem like a big area that is improving that much. But if you see the improvement of the metrics across the years, we basically are getting like a day of forecast every decade. So if you compare like the forecast from like the yellow line is like 7 days in the future, with respect 5 days in the future, with 10 years of difference of research, we are getting a couple of days of forecast. So if that trend continue in a couple of centuries, we'll be able to predict the weather for centuries or something like that. Just if we maintain the same technology. Partially because all of this depend on super big computers. I think one of the biggest supercomputers in the US is just used to simulate the weather of the world. And that's it, this is amazing. But of course, when you search the weather in Google, it doesn't work that well. Like if you have ever tried to search for the weather right now, most of the time the results are terrible. So how come we get these like nice numbers, but at the same time, the experience is so terrible? And the reason is that, well, as always, the infrastructure in Africa is not the best, and it's something common across the whole global south. So this is a map of high quality weather radars. That is the best way we have to, for instance, measure precipitation. And if you see, it's basically superintends in the US. Almost every point in the US, we will know if it's raining or not. It's kind of the same in Europe and in China, but in Africa, it's sad. I mean, maybe South Africa, they have good numbers, but the rest of the continent basically don't have any sort of data. And this is particularly problematic because the weather in the equator is quite different from the weather in the north. So if you have friends or like you just search movies, you usually don't see like that much heavy rain as you see in Ghana. And of course, stuff like Hamatan are just something that doesn't happen anywhere else. So we don't have a way to collect the data, and we have a really unique weather here. So that's like the perfect mixture to make this model super bad. And to make the things worse, the second best way to get data is like to directly measure the data in ground using the station. So every time it rains, there is like a small bulb that collects water, and based on that, we can know how much rain is flowing. The problem is that we, in Africa and in many other parts of the globe, this data is not digitalized. It's literally just in books, stored in some weather agency. Probably some of them are stored here in the university. Also, like the plot is kind of cheaty, well, the second one, but the third one shows the same story. The number of weather stations is decaying. The main reason is because maintaining this infrastructure is expensive, and it's probably not the most popular thing to maintain. If a government needs to save money, they will not say, hey, we need to continue maintaining weather stations. They will focus on something that is more easy to see, like the roads or the schools. So the amount of weather station is also decreasing with time. That is something that should be the opposite. So all of this is because, so we don't have really good data, but to make the things worse, the way the things were, like this analysis method that takes the current forecast and use the data that we have available to make an adjustment of the forecast, works really well when we have a lot of data. But if we just remove a couple of data points, the analysis is completely different. So the fact that we don't have a lot of data in Africa actually hurts the performance of these models, because these observations can be noisy at some point, and because we don't have a lot of data around, these basically end up destroying how we think that is the best estimate. So when we go back to this plot, so you see that like every line has like a top line and a bottom line. The top line is kind of the performance in the global north. The bottom is the performance in the global south. But it's making the assumption that the data is correct. So this is even worse than it looks. So yeah, that's the reason why the weather is so bad in most applications. To make the things even worse, we actually need this technology in Africa, because farmers and other entities rely too much on the precipitation. So most of the farmers in Africa, they completely rely on just the rain to maintain their crops. And if they don't know anything about the forecasts, it's kind of hard to make plans. So for instance, if a farmer in Ghana decides to put some pesticide, it needs to pray that it will not rain soon, and it will lose all the money. And aside that, because of climate change, there are more weather catastrophes. They are getting even more common in Africa. So it's kind of annoying that the areas that we need the forecast the most are the areas where it is the worst. The thing is that we have a lot of underutilized data. So a lot of different agencies have collected a bunch of data that maybe is not super useful in the global north because they have better alternatives, but they might be useful. And usually the meteorologist community have been overlooking this data because they have better alternatives in the global north, but we believe that if we utilize this data on a better manner, we can get better results in the global south. So the question that motivated my team and our research is, can we use machine learning to produce a better forecast? So the point here is that we are not using machine learning for the sake of using machine learning or because it sounds nice and fancy. It's because it's the best way, or we believe it's the best way to utilize observations that we have available in the continent. And we can produce a better forecast on a different way than any other agency in the world. So the idea will be simple. We want to take as input a highly available indirect measurement of weather. So we want to have a signal that will tell us whether it's raining or not. And that is basically available everywhere for a cheap price and ideally with a nice latency. So we can take that data as an input of a model and make a nice forecast. And of course, our target will be something that is high quality. It might not be available everywhere or every time, but if it's available sometime, somewhere, we can use it as a target. And our whole point will be to try to densify it and make it be available at any moment. So let's say in this ideal world where this model works, we are taking the indirect measurements from whatever and trying to estimate high quality measurements. That's what we call estimation in this talk. So the first part, the highly available indirect measurements are basically satellites. So we have a bunch of geostationary satellites that are basically satellites that are always in the same position, pointing to the more or less the same area. This is one owned by the European Union, so they're trying to have some idea on where are the clouds in Europe, but they also need to take pictures of Africa because are in the same latitude. So we can actually see what's happening in the continent. They are only not having like these visual images, but they also have other bands that give us information about the temperature of the pixels. So if we know that a point have a cloud and it has like a low temperature, it probably means that it's raining. And like even new versions have information about lightning and other phenomena that will help us to understand where it's raining. So in principle, we can know whether it's raining or not with those images. But of course, it's not as simple because we don't know how a particular set of pixels translate into rain. And that's where machine learning appears. But we need, of course, a high quality measurement to use as a target, as a prediction. In particular, NASA owns a set of radars that are moving around the Earth. These are low orbit satellites that are measuring the reflectance of the clouds. So every time they are passing around, this is really a small band that is passing over the Earth, and every time they pass over a cloud, they will get a small measurement of whether it's raining or not. And they maintain that product, and it's like really reliable and can be used in station. So it actually looks something like this. We have a really small amount of data every 10 minutes or so. But if we collect data for 20 years, we can actually train models using that information. The problem is that rain in particular, it's something weird. You have a weird distribution. Most of the time it's not raining everywhere. So if you try just to train a model and you predict the value of the precipitation, most of the time will be 0 because most of the time there is no rain. And then the model just will think that that's how everything looks. So most of the times if you predict nothing or just predict 0, you will get an interesting performance. Sometimes we have a slight rain. So maybe the model will get some data from that. And there are some extreme rare cases that are also really important because we want to know those cases. We want to be able to predict those cases because they have a severe consequence in the life of humans. So what we decided is to create like 2 models approach. One model that is just trying to predict whether it's raining or not.
Wants to run Windows 11.
Okay, so it's quite simple. It's just like binary classification. We receive every pixel and we say, okay, it's raining or not. And where there is no GPN sub, when we don't have data, we just ignore the prediction at that point. We just mask it in the loss. And we have another model that, given that we predict whether there is raining or not, well, when we predict rain, it predicts the intensity of that rain. So in that way, we can have like a more balanced distribution and actually make reasonable predictions. So after all of that, we have something like this. This is just like a really early result. And of course, I mean, it's just blobs over a map. It doesn't mean anything. But when we compare with other agencies, we have like numbers that are interesting. So this CSI is something like F1 score for what matters is just like a good metric for measuring precipitation. And we have a different intensity of rain. So we have first light rain against other baseline that I will describe soon, and so on and so forth. So the thing that looks like yellow, iMerge Final, is a product that is available every 3 months. So NASA compute that product using all the information that I have available in the world. And after 3 months, they produce the best estimate given the data that they have. And we're able to outperform them on light and like low intensity of rain. And on medium and heavy rain, we are kind of competitive. And extreme rain, we are worse. But it's quite remarkable because in this estimate, with a late 3 months. So we can provide like sensitive information in a reasonable time. The next one, iMerge Early, is produced with a latency of 3. They are just GPM swap that we are using, and we're producing better results for every bucket of precipitation. And then we have PRR that basically are doing the same that we are doing, but using like simpler models, and the results are kind of shitty. But of course, like estimation is like a nice pet project. It's a nice way to get information about weather everywhere that is like reliable and time sensitive, but we really care about forecasting because it's what the users actually need. They don't want to know if it's raining or not. You can just go to your window and check that. They want to know if it will rain in the near future, especially like the next 12 hours or so to make plans around that. So our new moonshot idea was to use this estimation model that we have and put all the information that we can also get globally in a similar way. By similar way, I mean that it's like highly available and reasonably cheap to use, and they are helped, like they don't have like really restricted license, so we can actually use it in production. And for context, this is the best model out there, like the best numerical model. This is maintained by the European Weather Organization. Is like the standard. The green line on top is the result in the US, and the red one is the results in Africa. There is a big different margin. The x-axis here represent lead time, so how far in the future is the prediction. At the beginning, like it should be easier to predict how will be the weather in the next hour. So that's the reason why usually it's going down, but it's kind of stable. This is a result in Africa. So for the first few hours, we are better than the best model in the US in Africa, which is quite remarkable. And in the next couple of hours, we are competitive with the numbers in the US. In every case, we are better than the best model in Africa. So, by the way, this agency have been working on these models for like 20 years, and we have been working on this project for, I don't know, 7 months or so. So, still a lot of area of improvement, and there's still a lot of things to do. So, we're optimistic that we can actually push the state of the art by a big margin. So, we want to believe that the future of weather forecast is in machine learning, not because it's fancy or sounds good, but because it's actually the best model, the best way to utilize the data. And this is particularly true in the global south, when like traditional methods haven't been really successful. So in case you want to work on weather, I'm starting a new community with some of my collaborators outside Google, so it's not a Google affiliated stuff, to work on weather stuff related in Africa. We are not only focusing on weather forecast, in fact we don't work on weather forecast in that part, but on how can we use this forecast and all these technologies to improve the life of people. So we planning to cover stuff like agriculture, or like early warning of disasters like floods and wildfires, but also energy prediction and everything that is related with weather. Aside that, my team is Google is hiring right now, so we are trying to hire a bunch of different positions from junior levels to senior levels. So if you want to join and work in this kind of impactful stuff, you can go to careers.google.com. There is like a bubble search for location, and just put Accra, and you can join our teams. I don't think the position is open like right now, because I don't know, the marketing team considers that better if they release it on a particular day, but I think it will be on like in 2 or 3 weeks. So if you want to join the team and work in these kind of problems, just present yourself. Yeah, that's it. Thanks you.
All right. So we have how many questions? Question Q&A. So we need two people, just two. If you have any question. Where's the other microphone? Where's the other microphone? Where's the microphone? Where is it? Okay. If you want to ask a question, let me have this one.
Okay.
Okay, thank you very much for your presentation. My name is Cletus Adongo. I'm an MPhil student, intellectual property. Presentation, okay, sorry. Your presentation was quite very, very educative. And I've always been wondering how whether people get their data. Hello. You just demonstrated that it's not magic, but it's true data. Yes, and I think you highlighted that there's that of a challenge when it comes to Africa, because there's really not much data. Yes, but yet we still have weather forecasting, and I also saw you indicated that there's prediction and other. I really want to know in terms of tangible, something in reality. How do we predict what's the name? The forecasting in Ghana, and if we don't have the data, what can we do to get that data for the prediction in Ghana and Africa? Thank you.
Okay. So if I understand correctly, the question is, we have problems, but we don't have data. What can we do? Right? Okay, so in the particular case of weather, what we try to do is always search for data that is like an alternative way to measure the same phenomena that we want to do. So these LEO satellites that we are using as targets are not something super used in the literature by other organizations because they have better alternatives. So I believe that there are many other projects and like problems in general that they face a similar situation. Maybe there is like a clear target that everyone uses, but it's not super available in Africa. But there might be other ways to measure the same phenomena that are maybe a bit more complex, but can be used to predict the weather. So for instance, my team is considering right now to use these trap cameras that are in the forest to measure precipitation. So in many parts of Central Africa, there is no rain stations because it's basically a jungle with wars and a lot of problems. And like with a big infrastructures gaps in those areas. So the thing is, like, there are many other teams that are collecting like photos of the animals around, and sometimes those cameras activate when it rains. This is a problem for the cameras. That's not the intended behavior, but we believe that we can use that and a bit of computer vision to detect certain levels of precipitation. This is still like a really early project. Many other teams around the globe have been doing something similar with like web cameras that people put in the city to measure the precipitation. but never have ever tried to do it in the continent. So we believe that it might be another interesting source of precipitation. And sometimes, I mean, something problematic with precipitation is that, I mean, so this is a big map. Oh, well, doesn't matter. So the point is that when we have when we are producing these models, we are working a really, what in the meteorology space is considered really high resolution, but for us it's like really bad resolution. So in particular, every pixel for us represents like 5 kilometers. So we are just saying that when we say that there is precipitation in that point, we are kind of talking about the average precipitation in that point, and sometimes like, you know, it's raining, but you walk a bit more and it's not longer raining. So it's not exactly perfect, and that also makes the evaluation a bit tricky. So having more like ground observations to actually know, like to actually have numbers to measure how the user will perceive the precipitation will make our life easier. So we are really focusing on that. And I think that's extrapolated to another problem. So I think in general, a good way to use machine learning is to take measurements that are not direct, but have enough information to tell us whether it's the phenomenon you're trying to measure, and then using it to, let's say, fix that gap. I think there's...
Okay. Thank you very much for your talk. My name is Bernard Hassan, and my question is, with the best models in the States, what is the longest in time, ahead of time, that we can actually forecast the weather?
Okay, I am not super... So in weather, there are 3 problems. There are basically 3 different time ranges. We are mainly focusing nowcasting, that is predicting what will happen in the near future, the next 12 hours. In fact, some things consider that the next 6 hours is nowcasting, and after that is something different. But yeah, let's say nowcasting is our focus right now, and we are trying to predict the next 12 hours. These other teams that are working in mid-range forecast, that is trying to predict hourly how will be the weather for the next 2 weeks. And there is also seasonal forecasts that is the problem of trying to predict how will be like for instance, when the raining season will start, or those kind of problems. So the thing is like, the time is not only the only factor, we also care about the spatial resolution. So when you are working on nowcasting, you really want to know if it's raining on a fine-grained resolution. So let's say on a horizon of 7 days, it really doesn't matter that much whether it's raining in like that part of the university or this part of the university. But when there is nowcast and you want to know what will happen in the next hour, that really matters. So different, let's say, problems also have associated different resolutions. Then for subseasonal forecast, you don't want to know when is the raining season coming to your home. You want to know when is the season coming to Ghana. So those different problems have also different spatial resolutions. To be more clear, most of those models, like machine learning is really good for nowcasting because it's really hard to get that information. Like the assimilation takes some time to actually work. So usually, let's say we are targeting the easiest problem for machine learning. But there are also other teams on DeepMind that are working on mid-range forecasts. So the team built GraphCast and GenCast that are targeting that particular problem, and they are performing quite well. But again, they are using the analysis as target. So they might not work that well in Africa. Although there is a new tendency of learning for them directly from observations. Aside that, there is also another team that was like recently published in Nature, and they are trying to tackle the seasonal forecast. So those are completely different problems. Some of them are easier for numerical models because it's easier to run a simulation over long-term horizons, and when you have higher resolution, it's cheaper to run those simulations. So yeah, I think that's it. Well, the other thing is like from a business point of view, nowcasting is more important for Google because people are usually searching for like the weather just to know what will happen today. So like usually people don't care that much if it will rain next Monday. It might be useful like if you are planning an event or it's your birthday or something like that. But for like the average user, they want to know if it's raining soon.
are the model inputs more of like numerical data or like images where you look at a computer vision problem, or it's like a multimodal kind of thing? And also, like which kind of model architectures you look at in like weather prediction? Thank you.
Okay, so there are two questions. One, how the data looks like, if it's like images or what. And the second one, how the model looks like. So in every cases, those problems are image to image. Like let's say the weather estimation is an image to image problem because we're trying to map satellite images to a basically field of rain or temperature or whatever other stuff that we are predicting. For the case of forecasting, it's more like a video because we want to have like some information from the past and we want to predict some information in the future. For this estimation problem that I show, we have a really simple model. It's just like a UNet that takes like the satellites and predict the precipitation. For the nowcasting, it's a bit more complex. We are using a UNet, but when you are predicting a video, you can do it in two ways. You can do it in an autoregressive manner. So you receive the current precipitation and you try to predict the next state, and you just do that in an iteration. And another way to do it is just receive the time as an input. So you get the current state of precipitation or the precipitation for the last 2 hours or so, and you also receive a lead time that is basically telling you, well, like, I want to know the precipitation at time t. Let's say time t is 3 hours. So your output will be how will be the precipitation in 3 hours. And the situation is that our best model is a global model. It's a model that receives as input the whole world and output the whole world. And the world at 5-kilometer resolution for the last 2 hours is like really heavy. But it's like 30 gigabytes just each sample. So because of that, we cannot have like super big models, and the recurrency becomes super expensive. So we decide to just use lead time. So the model basically is a big convolutional network. I think it's like more or less the size of BERT. I think like 1 billion parameters. And the input is all the weather information that we can have, but like in a single image. And we predict also the whole world. So it's kind of a big problem. So it's probably not super accessible. But there are things that are working on. Like I think initially we were using just Africa or just Ghana. But like one thing with weather is that like the information of the neighborhood is really important. So when you increase this field of view, you end up improving the performance. Some people say that we don't need to actually see the whole world to predict the precipitation for the next 12 hours. But using our model, we can easily get to 10 days. But that's still our research in progress. Yeah, there's, yeah. Oh.
Hi, thank you for your presentation. It was very interesting. My name is Elom Goka. You mentioned in your presentation that the models that you built for Africa were better than other existing models for Africa. I'm curious if you could provide any insights as to why you think the models that you built had a better performance. Was there more data or different types of data that you used, or was it due to the techniques that you used? Thank you.
Okay, so I think that there are multiple reasons. So there is a big problem on traditional numerical weather methods, and it's called parametrization. So to not get super technical, fundamentally, so I think one big difference is that we are optimizing for different stuff. So when the European organization is building their models, they're optimizing for their area. But when we are building our models, we're optimizing for Africa. So when we are tuning the parameters, when we are choosing the structure, we're trying to optimize for the global south. So in the end, it's kind of expected that if we're optimizing for a particular objective and they are not, we will be better eventually. So I will say that that's the key difference. There are some small technical decisions that we made that might be suboptimal in other regions. So for instance, our model performed really bad in Europe, but we don't care. We have other models that are already in production in Europe. So I would say that those small technical decisions are the difference. Also, we are choosing the data that we consider that is the best in Africa, but it's definitely not the best in Europe. While the other agencies, they are optimizing for their target public. So we are not better because, I don't know, we have a superior method, although I believe that we have a superior method, but probably the key reason is because we are focusing in this target. And there is a big problem, or a big elephant in the room at Google, is that we don't know how better forecasts translate into better user experience. So we know that the forecast in Africa is not usable. Like, you don't search for the weather most of the cases because you don't believe that it's true. We don't know if our model will be that good. Like, we don't know. We are planning to launch in Ghana soon in Google numbers, like maybe in the next couple of months. We are hoping that that will translate in more usage, and that will translate in more money for Google and like success for us. But it might be the case that there are a lot of different factors. Like when you're building a machine learning system, it's not only about, or machine learning product, it's not only about the model, but everything that is around. So it might be the case that the interface is also not optimized for Africa, and we are missing a bunch of opportunities. So there is still a lot of stuff to do. We believe that we need more of these kind of projects where we optimize for the needs of our users, and we have a bunch of users in Africa, so it's definitely worth it. But yeah, like I think in the end it's a more complex problem, and we haven't thought that much. Or would say when we are building those models, having these other numbers is more to compare. Like when you see a curve, it's kind of hard to know if it's good or not. But you need like a point of reference. So when we are comparing against the best European model, it's not to say that we are better than they. That's something good, but it's not our objective. It's more to put some context to our results. So even some people can argue that it's not really comparable to see numbers in Africa and numbers in Europe because the weather is different. So if there is more extreme rain in Africa and your performance is likely worse, it's expected because you have a larger sample and some more stuff. So it's kind of, it's like if I was like talking with the people that is building those models, they will probably have a lot of caveats about our results because it's not super apples to apple comparison. Like we are optimizing different stuff. I don't know if, I say a lot of stuff, but I don't know if I solved your, okay. Okay.
Okay, thank you very much. And myself personally, I've been using the weather data, that's the CHEPS, for my final year project. And the issue I faced, and I think it links with the theme for this, unleashing the potential of AI through grassroots engagements. And the issue I face concerning the grassroots engagements is they do not believe in the satellite data. And I'm doing my work on Google Earth Engine, and they do not believe the satellite data. They prefer the ground data much more than the satellite data. So I'm asking, is it that you are only using the satellite data for your machine learning, or you're also incorporating the ground data into it?
Okay, so sorry, I didn't understand. I understand the context, but not the question. So
yeah, so I'm asking, most often they do not believe the satellite data, that's the radar, the images take very much as compared to the ground data. So I'm asking the machine learning models you are running, I know that you run with maybe some previous weather samples data. So I'm asking the sample data, are they ground-based data or is only radar?
Okay, so I think I can answer the question in two ways. We don't use that much ground stations because it's, how can I say it in a way that it doesn't sound bad? So the thing is, like, the weather agencies don't like Google that much and they have good reasons. Because we are a big company, so let's say it's a kind of power battle. So Google is a big entity. We can go there and buy their data, but they only have their data. So like a big problem that face many agencies in Africa is that they want to do more with the data. They don't have a big stream of income for multiple reasons. So creating those deals is kind of complex for us. Usually, like the agencies want more money than the one that we can pay for that. I mean, Google is at the end a $1 trillion company, but we are really a small project inside a big company. So it's kind of hard to fix that problem in the middle. So from one side, they want to keep their data, and from our side, we believe that we have other ways to do the stuff. It would be great to have more collaborations with like weather organizations that will provide more data. But in the end, we don't want to be like a bad company that just go get their data, get the results, and then escape. So it's still kind of hard to create those partnerships. Also, like getting a partnership is not something trivial. There is a bunch of legal stuff that we need to do. If you want to use that on search, you need to get a commercial license and all this stuff. And there are a bunch of different countries in Africa that have their own data, and it's kind of hard to go each like country by country asking for their data and like making those deals. It's not like super scalable. In fact, like we were trying to contact the agency of South Africa. Well, I don't know if I can say names, but well, the point is that we don't have the best like an ideal relationship with those agencies because we have different interests, and it's kind of hard to get to a middle point. On the other hand, to not just say the present stuff, I think when you are working on an organization, you need to know what are the strengths of your organization. So working with this data is really expensive. Like our global model, the input size is really big, and that requires a lot of compute and also like the knowledge of how to use that data. And thankfully, we have that at Google. At Google, we don't have those stations, so we try to use the stuff that, like let's say, our competitive advantage to produce the best results. And of course, other agencies that, let's say, maybe don't have as much computer, as expertise to work with this data, they will focus on the stuff that they can do well. And that's great for the ecosystem because like we don't believe that we are doing the best stuff in the world. We are doing the best stuff that we can do given opportunities. So the fact that our organizations are also building their own models or their own stuff using information that have available can teach us how to better utilize that data and maybe use all that knowledge around to go to these stations and create a more organic relationship with them that is actually worth it for both the company and the organization. Because in the end, we don't want to get in this weird position where we go to an organization, we pay what we believe it's fair, but the other organization don't feel that we are making a fair treatment, because in the end, we want to have a positive impact in the ecosystem and not like the opposite. I think there is one last question, if it's not a problem. The guy have been trying to.
Thank you very much for your insightful presentation. My question is on data. In your presentation, you exposed us to the fact that we don't have data. And if you have to solve our problems as it persists here, we need to have our local data, because no two systems work exactly the same, so we cannot use global data, maybe US data or Europe data, to solve our specific problems. Google, are you trying to do something like that to help our students? Because my experience is that in most cases when we are learning about these technologies, you will have to be learning the technology around foreign data, which might not exactly be the problem we face. In your work around our region, is it also part of what we are doing to help? I think you might not have all the answers, but just to the extent that you can answer. Thank you.
Okay, so I think the question is how Google is trying to help the data scarcity in the continent. So honestly, I don't know. I mean, I think there's a bunch of problems, and one thing that you learn when you are working on like high impact projects is that you need to prioritize, and a part of the prioritization is understanding how can you have the best impact on a community. So again, we have some competitive advantage, especially at scale, and we want to use that advantage to help the community in some way or another. So there are some situations when we can collect data and share it. It's legally and it's good for Google and it's good for the people, and we do it. A good example of that is open buildings. So basically, a couple of years ago, Google Maps, in Google Maps, we have like buildings, of course, and like when you see a particular face, you can see the buildings as an object. And we use that to map the world. Like when you are searching something on Google Maps, we try to associate that with a building. The thing is, like in the global north, there are institutions that collect that, but in Africa, and especially in many African countries, there is no such a thing. So when you, in the past, used to search for Google Maps, you basically, like areas that were super dense on buildings, you don't see anything. So one of my teammates started a project where we use satellite images to map the world. And we, like right now, that's what we are using at Google when you put on Google Maps. And we can just end there the story. But we believe that a good way to increase our impact was to share that data with the community. So we released that data in Africa. You can basically right now download the location of all the buildings in the continent. And then we extended to Southeast Asia and to South America. And this year we are close to release a temporal version of the dataset that tells us how the buildings evolve across the years. And we believe that that can be used by a lot of organizations to, for instance, measure, like to make better planning for cities and to like make census and those kind of stuff. That we as an entity, we are probably not super interested because there is no clear business for us, but the other entities might use it in a positive way. On language, we are trying to do the same. We are trying to collect some language data and share it when it's possible. But something that it's important to understand is that sometimes there are legal considerations when you're sharing data, because maybe we acquire that data under some policies, and it might not be feasible to share it. Or some other times, to be honest, there are some business reasons why some persons on the company don't want to share it. So for instance, this building mapping, we also use it to map roads, to improve the roads in Google Maps. But we weren't able to share it because it would be really easy to make a competition. So it's kind of hard. As an engineer, like we would love to share everything that we do, but there are like bigger forces. So yeah, we always try to have a positive impact. Maybe sharing the information is a positive way to do that. But I think in general, there are also other ways to do it. So we want also to share compute and to help students when they have cool ideas or cool models, because we also believe that Google is not the only place to have great results. So, well, as a side note, if someone is working in something cool and they need compute, they can text me or test us, and we will see how can we do it. Of course, like compute is not free for us, so we have limited budget and we'll need to do some prioritizations. But yeah, in general, we're just trying to have a positive mark. I guess sometimes it's of course inevitable to have like a negative consequences or to act in suboptimal ways, but we're just trying to improve over what exists. So I hope that answered the question.
Thank you. Please, we can do it better for him. Thank you. So, Mr. Emmanuel Asante, if you are here, kindly see Nana Kojo at the back. Mr. Emmanuel Asante, if you are here, wave. Okay, please see Nana Kojo at the back. Thank you. Is it gone? Okay. We are going to take our next presenter. Let me read something small. I have to edit and edit and edit. She's a very big woman. All right. She is a senior policy advisor at the Tony Blair Institute for Global Change, specializing in digital ID and digital government transformation. She also focuses on using technology to improve public sector efficiencies and service delivery. She collaborates with governments and the private sector to advance policy reforms and thought leadership. Her work aims to harness technology for societal benefit, especially in Africa. She also advocates for data-driven policies that promote inclusive growth and efficient government operation. Ladies and gentlemen, it's with my singular honor do I present to you Madame Hilda Barasa. Give it up for her. Oh, clap. One day we'll be clapping for you. So you use
Hi, good afternoon. Oh, good afternoon. Okay, I was about to ask if people had fufu or wache for lunch. One of my first meals that I had in Ghana, I've lived here 3 years now, was fufu, and I've never gone back to the office just feeling very sluggish and sleepy. So I hope that was not the case. Thank you so much for having me. It's a pleasure to be here in Kumasi. It's my first time. And I'm really liking the Kumasi vibes, and I wish that I had more time to spend here, but I'd love to be back. As Mr. Maffa said, my name is Hilda Baraza. I work with the Tony Blair Institute, and I'm going to plug this. I don't know how many people know about the Tony Blair Institute. We have been in Ghana for almost 6 years now, and Ghana is one of our 17 countries that we work in on the continent. Primarily, our work focuses on supporting government leaders, the center of government, to deliver on their strategy and their policy. So we work on strategy, policy, and delivery with technology as an enabler for all three. And in Africa, and in Ghana, in the Ghana office specifically, we always run annual summer internships. The call usually goes out around May. Did anybody see it here? Okay. Please take note of it. Every May, there's usually a call for summer interns who work on really cool projects, whether it's in the government, on the policy side, on the delivery side of things. So, to jump into the presentation, when we talk about public services, how many people here enjoy their interaction with the government? By show of hands. How many people wish it could be better? Fantastic. And do you wish this at a national level or at the grassroots level? Where do you get most of your services? Grassroots, yeah. So when we think about how public services run at the grassroots, where most people tend to have it as their first point of contact with the government when you're seeking a government service, it could be something as simple as registering for a subsidy or getting your ID. In my country, I come from Kenya. When you're trying to get your ID, they send you all the way back to your home village. Even if you've never gone, you have to go and find your chief to sign off on a document and say that you're from that village before you can submit your application. So my very first interaction with the government, it goes back all the way down to my village chief. So it's important that when we think about how governments are using technology, it has to be cascaded all the way up. It shouldn't be top level. It needs to come all the way down to our local governments and our local authorities. Presently, we talk about 3 key AI technologies. There's machine learning, which I think almost everyone now has interacted in one way or the other. How many people use ChatGPT, OpenAI? Oh, your lecturers are not here. You can raise your hands higher. Yeah, we're seeing more and more. When I was in college, when I wanted to do research, I had to go to a library similar to the one that you have outside the building, where I could be able to look up the codes and I'd know which books exist, and then I'd have to read the books to get the kind of knowledge that I want. But nowadays, it's very simple to just use Perplexity, Lumina, to use OpenAI, and you just put in your question, it tells you the kind of information you're looking for. Nowadays, you can get sources from your queries. So there's that. And then we have natural language processing. One of the projects that I'm really happy about and excited about in Ghana particularly is the Ghana Natural Language Processing. So this is an open source initiative that is trying to process Ghanaian languages, starting with Twi, which is the more widespread local language, and trying to apply that to issues that we're facing. So a lot of, there's some nuances that are lost when things are translated into English, right? So there's some things that you will get when it's said in your local language that doesn't necessarily always have the English equivalent of it. So when you have things like the Ghana Natural Language Processing Project, you get excited. You know that for what does it mean for inclusivity for everyone who's seeking a public or a private service. So quite excited for that. And then, the third one would be around computer vision. So if you think about autonomous vehicles, object recognition, self-driving cars, which we're a long way from getting them. We can imagine trying to drive that in the streets of Kumasi or in Accra, and a trotro just comes, or one of the boda on the motorcycle comes. It just kind of makes it a little bit difficult to have autonomous vehicles at the moment. But our governments in general are recognizing the benefits of AI in public services. So hello? Oh, yeah. So in Rwanda, for example, they're using AI in 2 primary ways. One is to address sort of like the procurement constraints that exist in healthcare. So there's a company called VBIG Technologies that has partnered with the Ministry of Health in Ghana. And basically what they've done is to connect hospitals and healthcare systems directly with manufacturers and to try and streamline the supply chain system for medical drugs, for equipment where it exists. So essentially everything from warehousing to distribution to management of inventory is being powered by AI. And then we also have Zipline, which also exists here in Ghana. So Zipline uses AI-based models for their drone delivery. So the drones are able to sense where do the obstacles lie, how does the drone bypass certain areas in its flight path to be able to move something from point A to point B. In Togo, there was a fantastic program, social welfare program during the time for COVID. It was called Novisi. So initially, when COVID struck, the country was shut down. The government gave people monthly stipend. But social registries that prove your eligibility for that kind of stipend didn't exist, right? So what they asked people initially to do was self-register. Identify yourself as somebody who needs money. Who doesn't need free money from the government? If my government decided to start sending me money, I'd never say no. So the issue with that is the people who are the neediest in the community, the poorest of the communities, tend to not get picked up by the system because you have other people who are self-registering, for example, in their place. So the Novici program used machine learning, it used mobile data histories. So there are people who will be able to afford 1 to 3 CDs of airtime data a day or a week. So you use that kind of proxy data to be able to identify who are the right recipients that we need to target for these, for the social welfare system. So I want to focus a little bit more on 4 key areas that I think are really important in the grassroots level, where I think you can have the greatest kind of impact when you use AI, when you leverage technology. And this is coming from discussions that we have with our partner governments, what we see out in the field, and giving you some examples of technologies or innovations that are currently happening within that space, and hopefully to spark ideas, because all of it is a growing field. I am in the room with some of the brightest people in Ghana, so I'm confident that you can hear these ideas, you can see where the need is, and you can innovate around that, particularly for the public sector. But also just to sense check that I nailed the presentation, if you could just yell out, maybe like 2 or 3 people, what are those areas that you think are really key for grassroots communities for the public sector? Any takers? Oh, I thought we didn't eat fufu. If you think about your grassroots communities, what are those public sector services that you think are particularly important that the government should be looking at? I have a hand at the back, the lady in white. If you could just shout. Banking? Okay. In blue? Transport, yes. The guy all the way at the back? Healthcare, yes. Gentlemen? Agriculture, yes. The lady all the way at the back? Education. 1 more or 2 more. So the lady? Security, and finally the guy in the plaid shirt or the check shirt. Sanitation. All right, fantastic. Now, all of those are really, really important. I have picked 4 out of the ones that you've mentioned. So I'm going to look at education, I'm going to look at healthcare, to look at agriculture, and then finally to look at social welfare. So the first one is, the first application that you can get is on healthcare, right? So we've talked a little bit about what Rwanda has done leveraging AI in their healthcare sector. And so when you look at this, we have 3 main things, right? So we want to use AI for disease surveillance, to use it for health service optimization, and lastly, to use it for telemedicine. Sounds, yeah. So when you think about disease surveillance, the office sent us a message, I think earlier at the start of this week, that there have been cases that have been identified for dengue fever, particularly in the eastern region, and then also just letting people know you want to watch out for mosquito bites, what those symptoms are that you should be thinking of, right? So that's kind of that kind of disease surveillance. And we can use AI to analyze data and to predict disease outbreaks, right? So things such as this, dengue fever that has been picked up in the eastern region, cholera, diseases that are really prevalent sometimes in some of the communities that we come from. There is an AI application in Uganda that is called M-Track. So M-Track is an SMS-based surveillance program that leverages AI to then analyze weekly disease and disease reports that are coming from community health centers, and they're analyzing all of these weekly reports from healthcare workers across the country to try and detect what those unusual patterns are and predict potential outbreaks. So this has been used for predicting outbreaks for Ebola, which usually tends to track up from the DRC into Uganda, and among other diseases, right? In Zimbabwe, we have Dr. Cadex. Cadex is using these deep learning algorithms to analyze chest x-rays from people and to predict what the presence of TB, where it does, enhance sort of like the speed and accuracy of diagnosis in the country. And then in Egypt, we have really good examples of telemedicine that's coming out. We have a program called Visita. So Visita uses AI to match patients to different doctors and different specialties. So you will go into a health center, they will, you'll speak to a nurse or triage, they will take your diagnosis, they will use it to say, okay, so based on what the system is coming up, what the doctor is saying, you kind of need to see specialist X, and the system will try and match you with the specialist who is closer to where you are. And so, one, it starts with online consultations, it provides prompts for follow-up care, and really you start to see behavioral changes in terms of how patients stick to treatment plans. And then there are lots of very interesting startups that I have interacted with that are not replacing, but they are complementing how nurses work in hospitals. So particularly as a fast port of call, nurses tend to manage a lot of the patient care that comes after you're seen or you're treated. So there are lots of different innovative startups that are now starting to look at how we receiving that sort of like after care that comes from hospital visits? How are you following up with your doctor? How are you following up with like your treatment plan? So lots of interesting AI startups around that field. So health service optimization, I already spoke about the work that's happening in Rwanda with VBEC technologies. And then the second one that I'll look at is on educational attainment, right? So access to quality education for all of us. I grew up when I was told at a very young age, education is the key to success. It sort of provides for you that kind of ladder. But more and more, our education systems are creating systems of disparity between the urban areas and the rural areas. There's a lot of limited resources. Countries that are very quick, whether it's a political promise to say we're giving out free primary education, free secondary education, are overburdening the system. So you have schools that currently will have 80 students or 60, 70, 80 students to one teacher. And when you have such a high student-teacher ratio, the fact is it's only the kids who are like super sharp who are going to excel through that system. The ones who are struggling will tend to be left behind or they'll fall through the cracks and nobody will notice until like years have gone by. In Kenya, when they had the free primary education, when they did sort of like an impact study afterwards, they're finding children who've gone up to grade 7 who actually cannot do basic literacy and basic numeracy. So what the program was trying to achieve was actually doing the opposite, because teachers just did not have the time or the resources to dedicate to students. So when we think about how we leverage AI to improve not just educational attainment and academic performance, but also to improve educational equity. Think about it in 3 ways, right? So there is personalized learning. how can we use AI to develop adaptive learning systems that literally allow you to tailor educational content to individual learning paces and the style of each student. It sounds like a very tough thing to do when you have 80 students to a class or more. How do you create such tailored opportunities? In Kenya, in Ghana, Nigeria, there are all these different startups that are trying to answer that question. So there's Mshule, which is using an AI-powered platform to try and provide this personalized learning experiences via SMS, and use the kind of data that they are getting at the back end, the kind of data analytics that they're getting at the back end, to then allow teachers to see sort of like the effectiveness of their teaching methods and to try and adapt. So you move at the pace of your slowest learner, and this is what they're finding in schools that are using Mshule alongside the wider curriculum. It allows teachers to see at the back end from that kind of data analytics of students who are they able to answer, some of the questions that are being sent to them via SMS. If we took sort of like a quick fire 10-second assessment, are they grasping some of these concepts? So that kind of adaptive learning is starting to come through. Eneza is another AI platform that was very useful during COVID with maintaining sort of like continuation of learning. And Eneza, same concept, right? It's all about how do you harness that kind of data that comes at the back end, beyond just saying we're providing the free content. What about the data analytics at the back end? Can you make that open to teachers and to school administrators? And then from that, start to think through how can we change how we're teaching? How can we change how we are connecting with students? And then the other thing is on teacher training. And I will confess that this, for me, I find it to be an area that still needs a bit more research, because I think we really need to understand more how teachers, both teachers and students, interact with technology. So it's not just about giving like the rosy, blue sky type of thinking around AI and tech, but it's about how do we, when you think about the practical areas, how do we use AI to lighten their workload? Can we use it to complement sort of like team teaching between teachers of the same subject matter, connecting them with the right kind of leading subject matter experts in their field or in their lesson plan? How can we help them to improve some of the professional development opportunities using AI? Can we lighten the load? Is it as simple as training AI to help them to simplify repetitive, right? So things like marking schoolwork. And this is why projects like the natural language processing become really important, because if you're using AI, you need to be able to train it to actually pick up and not to transfer bias to students who are not thinking, are not responding with English as their primary language. So some of these are the questions that we need to answer when we talk about teacher training and how teachers and students all use AI, and not just AI, but also technology in general. The third thing is on social services. The Novisi program was a really good African example of how AI was being utilized to analyze data, to design more effective welfare programs that really tend to address sort of like the communities. Other ways that we've seen this being in place is in South Africa as well, particularly for needs assessment. The greatest thing about social welfare programs And I see this, it's not just about the, the kind of social funds that you give people. It applies to agricultural subsidies. It applies to anything where the government sort of like gives a hand to plug a need or to bridge a gap. The greatest challenge that most people have is on how do you identify who are the right recipients, right? Because if you don't know who are the people that need to be targeted by a program, you're undermining its effectiveness. You're also creating a lot of room for graft, and the people that are meant to benefit from the program don't even benefit in the end. So alongside the basics of getting a digital ID in place to be able to identify some of these people, it's can we use data, can we use AI to be able to cut through the process of a normal a normal means test, and to be able to do proxy means tests that are a lot more accurate in identifying people who need it, right? And this is what the South African Social Security Agency did. So it took them about, typically they usually give a social relief of distress grant, which is about 350, 400 rand. And what they have done is that they sort of sat down and realized over the 15 years that the program has been running, they've only ever been able to enroll 7 million people. But the need is far greater than the 7 million people who are receiving this grant over a 15-year period. So then they have used AI to be able to develop proxy means tests, right? So things that use individual or household characteristics to be able to identify people who are in need. And in 6 months, they were able to enroll 8 million more South Africans into the program. So AI did for South Africa what the normal tests took 15 years to do in 6 months. So there's a lot of promise for how we can be able to use technology, how we can be able to use AI for some things. And then lastly, when we talk about agriculture, a lot of us come from agricultural areas. Chances are your parent, your grandparent, someone in your family owns a farm somewhere, or even if they live in Accra or here in Kumasi, they're growing something in the rural areas. So the challenges that Santiago talked about, whether machine learning to be able to predict weather patterns, that's one of the things that it's like one factor of the equation. There are other things about precision farming, for example. Something that always fails farmers at the end is you can all grow something. So this season we say, my God, tomatoes have been very expensive even in Accra. So now farmers ramp up the production of tomatoes. The problem with that is if everybody ramps up the production of tomatoes, when it comes to at the end of a season when you're taking it to market, there's too much supply. So all of you get a really bad and a low price. And so, yeah, you're ending up with losses instead of the profits that you envisioned at the start of your planting cycle. And there was a company in Kenya called Twiga Foods that unfortunately went under. But in the days, Twiga Foods tried to do precision farming. So what they did was they looked at the data, the seasons, looked at market seasons and market prices, and what they tried to do was to predict the demand for the various agricultural products that they were seeing. Kumasi loves yam, so there's a bigger demand for yam in Kumasi. In Accra, there's a bigger demand for eggplants or the bitter leaf or any of those other products, right? So they tried to predict this demand for all these various agricultural products across all the different regions to try and match supply and demand more accurately. And what this happened was in the first few years when they were running and they had the funds to be able to do this, they were starting to see a reduction in food waste in some of the agricultural regions or the areas of the farmers that they're working with, and also they were able to guarantee their farmers a much more fair price for their products. So there is that aspect of precision farming that we can use AI to be able to support. And then the other thing is on pest and disease management. Unfortunately for a lot of our countries, mine included, extension services for farmers is either non-existent or it's grossly underfunded, so it doesn't really function. So when things like armyworms or different diseases attack crops, farmers don't know at the start what to do to even prevent further spread of a disease, or what can they do for pest control. And so you start to see, there's a need for this. How do we help farmers, one, to try and predict these pest infestations and disease outbreaks and to allow them to take preventative measures? We've had the north of Africa a few years ago, the north eastern side of Africa had a bad case of armyworm, a really bad case of locusts. The agricultural ministries failed to do. Again, it was very comical seeing some of the solutions that they were trying to push once the infestation it had just really gotten out of hand, because the locusts were coming down from like the Yemen side, coming down to the north and the east of Africa. But yeah, some of these things could have been easily, like you could have kept track and predicted some of these things and known this is the trajectory, or this is the direction that they're coming. So eventually in the end, we had, farmers running through fields, banging on pots and pans, trying to make noise to disturb the locusts to move. They were trying to spray them from the air, but it wasn't quite working. And so by the time the cycle sort of fizzled out, there was, the losses were staggering. I think regions lost, a whole seasons of agriculture was completely just wiped out, right? And it takes a while for people to recover, because then the government also has to go into recovery mode, because now your food security has gone down. You have to start providing for people basics such as food. And then the last is on water management, right? So a country like South Africa is water scarce, and so they need to figure out how do we ensure, particularly in areas where they're doing irrigation, how do we ensure that there's water efficiency for farmers in the region? And so they're using AI to optimize irrigation schedules based on real-time data, trying to conserve water and also improve crop health. But all of this sounds very rosy, but we're faced with challenges, and it's important for us to be able to recognize these challenges. I'm going to just pick on 3 of them. One, because I really want to debunk the aspect of saying Africa does not have data. I find that to be a very, very misleading statement. And I get very annoyed every time I sit in rooms where this is said, because we create a lot of data. Everything that you do is a data point. Every single interaction that you have is a data point. When you wake up in the morning and you're craving wache, or you've gone out at night and you want night wache, that's a data point. When you go to a seller and buy wache, that's a demand data point. So when we say Africa doesn't have data, it's false and it's misleading. It just needs a bit of reimagination about what do you mean by data, and how do we get this data into the right format and the right structures that can be used by companies such as Google, for example, right? So in the public sector, I see this a lot. Our governments sit on huge amounts of data that are drawn either from censuses, that are drawn from the daily engagements that citizens or residents have with their local authority offices, with their national authority offices, and even from regular research, because every single country has research institutions across all the different sectors and industries, and they all sit on huge amounts of data. The problem is that this data is not always in formats that allow for quick analysis, right? And we've gotten to that point where we want to just like say, here, like just analyze this and it comes, in the next 30 seconds you have like all the insights that you want. But you need a bit more elbow grease when you're trying to interact with the data that's there. So it doesn't always exist in the formats that allow for easy analysis. Sometimes it's all paper-based, and sometimes it's just really unstructured, right? But if governments, if innovators took the time to clean up this data, there's a lot that can be done with this that can allow the simplification of repetitive tasks, that can open up a whole new world of possibilities, right? So I work in government transformation, and we're always trying to build advise governments on new data architectures. And the question is always, how do we translate the data that exists in Ministry A? Because the problem is all our ministries, and for majority of the governments that I've worked with, is that ministries and governments tend to work in silos. So if you have 47 different ministries, those are 47 different systems, right? So it's not always that you'll find that a government has signed a central contract for the different ministries to use for internal data management. A data exchange layer typically doesn't exist. It's why even up to today, if you're applying for a service that you need 3 or 4 different institutions to sign off on, you will carry your paper application to Ministry A, get it signed off, go to Ministry B, get it signed off, go to C, go to D. So by the time you're actually getting that service, you've really worked for it, right? And in the process of also working for it, you've also maybe paid outside of the system for it. So the challenge that we usually have is how do we make systems speak to each other, right? And so this is where things like APIs come into place. So if you identify the problem that you're trying to solve, and you identify that you have model A that requires data to be in this particular format, can you build an API that can allow you to translate the data that exists in this format for this format? And it's not just an African problem. Even in the UK, where we're working on their digital ID issues, they have so many legacy systems that getting such a system in place beyond just the political angles of it becomes very tricky, because you have to be able to build APIs that allow or build new data exchange layers. And that primarily revolves a lot around APIs. So the fallacy of there's no data in Africa, please debunk it. It exists. You just need to be able to put a little bit more elbow grease to be able to do it. And then I'm also a policy wonk. So at the heart of it all, I breathe policy. It's part of like my daily bread and butter, and it's been very useful to see how the regulatory and policy landscape for AI on the continent is evolving. At a continental level, we have an AU working group on AI. We have an intelligence blueprint that was developed by South Africa in partnership with Smart Africa, when South Africa used to be the chair for this. We have the African Commission Resolution 473 that looks at the impact of human rights, the impact of AI on human rights. We have the Malabo Convention, which has done really well. I think now we have about 38 countries that have data protection measures in place for automated decision making, or they're putting in place this data protection frameworks. And in 2022, not even that far back, just 2 years ago, there wasn't a single African country that had dedicated AI legislation. 2 years down the line, I think back then we had Mauritius, which sort of like had a partial AI legislation, but 2 years down the line, we have 6 countries that have put together their AI national strategies. We have a lot more starting to think through this or putting together task forces to work on it. And so there are signs of progress picking up because a lot more governments are recognizing that AI and generative AI, which has been there for a while, but it's gotten a very big push, is going to form part of their national priorities, development priorities going on. And then it also goes without saying that financing is an issue, right? AI innovations are expensive. And so just looking at the long list of challenges that are there, from limited access to infrastructure, both internet and power, from data quality to the skills and knowledge gaps that we have, and even the ethical considerations of AI. How many people know of WorldCoin? Or have heard of you've heard of WorldCoin. WorldCoin was trying to build a new form of digital ID for everyone. So they're like, we're going to create a new identity for everyone. And what they did was they were going into countries and essentially offering people 50 crypto tokens to be able to take your iris and your fingerprints, right? And this is sort of like the kind of biometric data that is very sensitive because it doesn't change. And so most countries, even right now, if you go to your National Identity Authority, they will never give you access to that kind of data. But because they were taking advantage of people wanting to get money, they were offering 50 crypto tokens to get people to line up and just sign away. Yes, essentially just sign away this kind of critical biometrics. So that there are all of these ethical considerations when you think about AI, because essentially they were using this data to also train their AI models. And this was from an MIT technical review. And so they ended up getting banned from a lot of different countries for such underhanded practices. But we have to think about this, particularly when we are using AI to try and solve our local issues, when these models were trained with either foreign data sets or they did not necessarily take into account your grassroots challenges or the local context. And so you might try and put a one-size-fits-all solution using AI that doesn't necessarily apply to your, doesn't necessarily apply to your context. So in summary, there are lots of challenges, but I think these challenges primarily are not insurmountable. I think the transformative potential of AI in addressing some of the grassroots challenges that we face in all the areas that everybody mentioned earlier is pretty clear. And there are innovations that are now starting to catch up with these challenges, and they're starting to show quite a bit of positive impacts. And it's possible that they will enhance efficiencies, they will enhance accessibility, and overall the quality of life that we're dealing with in grassroots communities. So, from my viewpoint, I think it's critical that we continue to invest in AI. We continue to collaborate. We foster those kind of collaborations between governments, between universities, tech innovators, NGOs, and local communities to really ensure that the kind of AI solutions that will be fronted for some of our grassroots challenges are primarily very relevant to our communities and they work for our communities. Thank you.
Oh, you can do it better. So please, just 2 questions. The first 2 people I see, you and her. Let me go to her first. I'll come to you.
Thank you for the insightful presentation. Please, you mentioned an Egyptian telemedicine app that tries to link patients to specialists, but I think I missed the name, so I'd like you to mention it again.
It's Visita, Vezeeta.
Okay, thank you. And also, you mentioned that you are into policy making. I want to know if you know of any ongoing system to generate AI policies in Ghana.
Yes, Ghana is actually in the middle of trying to develop an AI strategy. That process kicked off earlier this year. I'm not 100% sure what the status of it is, but yes, it's ongoing. Sorry, the guy, sorry.
Thank you so much, Madam Hilda. My name is Joshua, and then I would like to ask, in your presentation, you made mention of some startups that were offering their services, and then you said they offer their services via SMS, if I heard you right.
Sorry?
Via SMS. Yeah. When it comes to AI, when we talk of AI, we also talk of usability, how well the intelligent user can use the system. I was wondering if these startups are offering their services via SMS. In your in your own experience, is it being delivered properly? I'm asking that because I have a solution that leverages SMS, and I'm facing some challenges. So I'm just curious if these startups are able to do it, then how are they doing it, and then how well is it working? Thank you.
Okay. So I think it's important to remember that Africa is a mobile-first continent. When it comes to all of these different types of technology that is being developed, the easiest way you can reach people is by developing a mobile type of interface, right? So when it comes to mobile, like banking, we talk a lot about financial inclusion, but it's not that people that are going to open new financial accounts, it's that they will sign up to mobile banking. So when you're trying to reach students, so the SMS application was primarily for students, when you're trying to reach the widest group of students, SMS is a very, it's an easier way of reaching even the child who is using a 2G, 3G phone, whose parent has a 2G, 3G phone in the rural or remote areas of your country. What you can do with that, it's not necessarily about the user interface, it's about the data that you pull from the interaction with that. So when I talked about AI, it wasn't necessarily focusing on the bit of it. It was focusing on the back end data that they were getting and the kind of analysis that they were able to get, right? So if a student is prompted to answer a question or to read through something via SMS and then to try and answer a question, if they get it right the first time, that tells you it was easy to comprehend. If they get it wrong the first time and you prompt them to do a different answer and they get it wrong again, at the back end, you know that how this particular question or this thing was phrased is not landing for the child, right? So they're not necessarily or intuitively able to get it. And if you have that kind of data set for 1,000 students who have accessed that particular SMS application, then you're able to then at the back end change. So you have that as a data analytic, as a data point, and you're able to change how something is structured for the end user. So I think it's critical to always remember we are primarily a mobile-first continent. In terms of mobile subscription, it's higher than most places. So even if you build for things that you're thinking about as, can this be scalable? You maybe want to consider that as an initial point. But the gold then is in how do you analyze the data at the back end that you're getting from the interaction with your solution.
My question is on the noise that is rampant in our data sets as we have them. As we embark on the AI journey, have we thought about the possible feedback, garbage that the AI will throw back to us because what we are putting into it is probably wrong?
Sorry, the fever for data?
Yes. For example, if our current data sets, from my thinking, most of them are likely not to be too accurate.
Yeah.
And AI works on data such that you get back what you put in, sort of. The implications of AI throwing back our noise back to us, have you thought about it, and what's the procedure in addressing those issues?
Yeah. So it goes back to data formats, right? So you need to be able to structure the data in a way that it allows you to query the data that you feed into an AI system or a machine learning model. And it's not always that what you put in initially is what you run with it. I think you always play with different scenarios, different data points, and you troubleshoot, and you go back and forth, and you ask all the what-if questions, and you're sort of like building that. When you're cleaning up that data, you have to start from that point of view. How do you clean up your data? How do you structure it in a way that then makes it usable for the solution or the AI solution that you're looking for? I hope that answers the question. Okay.
Good afternoon. My name is Nelson, and my question is in a different direction. So everyone who has come here today to talk has talked about data, has talked about why we need to collect data. Everyone has spoken about how we should collect data. Everyone has spoken about what they are using the data for. My question to you, Ms. Hilda, is how can we as citizens or as human beings be sure that the data collected about us or based on us will be used appropriately or responsibly, or the data taking about human beings from social security numbers to bank account numbers and all that, how sure are we that all that data collected would be used responsibly by the government? And it says you're a senior policy advisor, which means you work hand in hand with governments to work on all these things. So then I think you're the best person to answer this. Yes, please. Thank you.
Okay. So when I was running through the session on sort of like the policies, I mentioned the Malabo Convention and the fact that African governments had ratified it. And we have 30 different countries that have now put in place data protection legislation in place. It would be good to spend time looking at what your data protection rights are, because typically they provide avenues for redress, right? So and I'll speak for the Kenya example because that's my home country. Our data protection laws actually allow you as an individual to sue a company that discloses your information without your permission. And this, sometimes it's something as simple as you receiving SMSs from suppliers that you've never interacted with because they got a hold of your number somewhere and started, sending you all of his unsolicited text, right? So our biggest telco company was taken to court on a class action suit, and they had to actually stop that and provide an avenue for people to opt out of their number being shared. You have these rights when you look at your Data Protection Act. And typically what countries will do, and a lot of the data legislation that we have is modeled after the EU GDPR, and that's one of the clauses that exists within the EU GDPR. So you might have a legal avenue to to protect yourself in that regard. It's also why when a company like WorldCoin came in, the courts, the data protection Commissioner's office was able to say you need to stop this. The courts told them that you cannot take that data outside of the country, whatever you've collected, so they put a stop to that. And then something else that I'm not sure you might be aware of this. A lot of our governments are actually very protectionist of data. It's one of the pain points when it comes to leveraging technology, because everything they want that data domiciled within the country. And it's a problem that we get with digital government transformation, because when you talk about getting data centers into the country, data centers are really expensive to run, but they also don't want any of the data to be domiciled in Google data center or an Amazon or an Oracle data center that is not within the country. And so some of these organizations will not commit to building a data center in every single country that they want to work with. So our governments, by design at the moment, they're actually very, very keen on data sovereignty and keeping that data in. So you might find that if you go back and just look at your legislation, you're protected in some ways, or there's a measure of recourse that exists for you. And the Kenyan Data Protection Office, at the moment, they're handing out really significant fines for people who have done data breaches.
All right. My name is Elvis. So because you are a policymaker, advisor, there's this question that comes to mind that people say AI in the hands of those who know how to use it would end up ruling society in a certain way. So there's this gap that's going to be established if education is not enforced for people who are sort of not disabled, but maybe not have the right opportunities and schooling to be able to understand how to use these technologies. So my question basically is, how are you giving out policies to ensure that gap is not so widened, and then people are not left behind whilst the others progress and become richer, leveraging on the technology of AI? Sure.
No, that's a very good question, because the aspect of creating awareness and educating end users for the different tech initiatives it's a big one, right? Speaking of Ghana, for example, we've been having a lot of interactions on what kind of use cases can we have for the Ghana card. So we have more than 90% coverage for it, but for most people, they got it because the government said you needed to get it, not that they are aware of what you can do with it, what kind of use cases are enabled on the back of the card itself. So for all of these big digital initiatives that we are part of on the advisory side of things, we always advocate for education and awareness creation for all of them. You tend to run into a lot of opposition when you push something that people do not understand what it's all about. A few years back, we did a digital ID research project in Cote d'Ivoire, in South Africa, and in Rwanda, and we were going down into the villages to try and understand what are the economic benefits that people are getting from the utility of the digital ID. And it's the same